Hi everyone and welcome to today's video. This video is going to be about graphs of the form ax plus by equals c. Now before we start the video, remember to like and subscribe if you enjoy, and remember you can always comment down below if you have any questions about the content of this video or any other maths question that you would like me to answer. So to start, let's have a look of a graph with the equation 3x plus 4y equals 12. So this is similar to the ax plus by equals c that I was talking about earlier. Let's just compare that then. So we can see that a, b, and c are all integers. This is what would be expected if you're asked to write a graph in this form. So we can easily rearrange this to a more familiar form, which we know is y equals mx plus c. This is hopefully the form of a graph that you've seen before. If you haven't, then please check out my other video. I'll link it down in the description. Our goal then to fully understand this ax plus by equals c form is to just rearrange it into our standard y equals mx plus c form. So let's do this now. Let's subtract 3x from both sides. And then we can divide both sides by 4. And we can see that we've converted from our initial ax plus by equals c form back into our y equals mx plus c. And from this we can easily interpret several things. First of all, the gradient is going to be minus 3 over 4. And also the y-intercept is going to be at the point 0, 3. So just to remind you, I'll label the gradient and our y-intercept. So if we're asked to draw a graph of this form ax plus by equals c, I would recommend that you always convert into our more familiar y equals mx plus c form first. So let's have a look at this example question here. My first step is going to be to convert this ax plus by equals c form of the equation into my familiar y equals mx plus c. Let's do that. So we have minus x on both sides, giving us minus x plus 8, divide by 2 on both sides, gives us minus a half x plus 4. So now we've got this more familiar form. What I'm going to do is I'm going to first pick out the y-intercept is plus 4. So marking that on the graph, 1, 2, 3, 4. This is going to be the first point. Now remember, when you're plotting a straight line graph, all you need is 2 points. And the easiest 2 points are going to be those on the axes. Of course, if they're visible on the range of the axes that you have. But for this graph here, it will be. I know that my gradient is minus a half. This is quite a tricky number to work with. It's a negative fraction, so don't stress too much about it. Just set the y value to be equal to 0. Okay, and this will make things a little bit easier. Okay, so we can subtract 4 from both sides. And now we can multiply both sides by minus 1, or divide both sides by minus 1 if you prefer to think about it that way. That will give us 4 equals a half x, and now we can just multiply both sides by 2. Of course, earlier I could have just multiplied both sides by minus 2, but sometimes it's helpful to get rid of the minus signs before you continue. So I can see that at the point where the y value is 0, my x value is going to be 8. I know that is where it's going to cross my x-axis then. So 2, 3, 4, 5, 6, 7, 8. Okay, so now I've got my 2 points. I can just connect those. Okay, and that is going to form my straight line that I needed to draw. Of course, I can extend this further if I wanted to, but for the purposes of this question, that is fine. Okay, let's have a look at this second example question. Once again, the first step is going to be to rearrange this form of the equation back into the form of y equals mx plus c. So let's do that quickly. Minus 7y equals minus 6x minus 21. So I've subtracted 6x from both sides. I would times both sides by negative 1 at this stage to get rid of all of the minus signs, and then divide both sides by 7. Okay, so now that I've got this, it's time to put this line on a set of axes. Okay, so I've got my set of axes here. Let's pop this line on them. The first point that I can easily pick out is, of course, the y-intercept. So that's going to be at 0, 3. You can see that it's plus 3 there where plus c is. So that is my first point. Okay, and now I'm going to rearrange it. As I said earlier, the easiest way is to get the x-intercept. So we can set y equals to 0. Okay, I'm going to keep working through this, so I can times both sides by 7, so minus 21 equals 6x, and so x equals minus 21 over 6. I can simplify this, so that gives us x equals minus 7 over 2, which if we write as a decimal, which I don't recommend normally, but here, because we're plotting it on an axis, might be useful. That's going to be minus 3.5. Okay, so let's pop that on there, minus 3.5. It's about here. Okay, and let's draw now our straight line. Okay, and there we go. That is our straight line of the graph 6x minus 7y equals minus 21. Okay, so let's have a look at this longer, wordier question now. We have here in the question an equation of the form ax plus by equals c, except x and y are replaced with the variables p and n. Okay, but we still have the form number, letter plus number, letter equals a third number. Okay, so the first thing we've been asked to do is to draw the graph of n against p. So it helps us out here in the brackets. It says put n on the vertical axis and p on the horizontal axis. So a word of advice here, if there is a letter against another letter, it's always the first letter that goes on our y-axis, in fact. Okay, so that's something to note in these questions. So let's get a set of axes and let's draw this graph. Okay, so I've got my y-axis, or should I say my n-axis, all set up here. And then I need to look at my x-axis, which here is the letter p. And I need to decide what range of values I want on here, because it's not told to me in the question. So what I recommend you do here is pick the extreme values of the first value. So the first value is n, the extreme values are 0 and 90, so the minimum and the maximum, basically. Let's put in n equals 0. That gives us 6p plus 0 equals 90. Okay, so if we divide both sides by 6, we get 15 for the value of p, so that's one side of the limit of p. Then we can put in a 90 as the other one, 6p plus 90 equals 90. That's going to give me p equals 0. So I need my x-axis to be between 0 and 15. So let's put that on. Okay, so now that I've got my two sets of axes, I can pop on this straight line by selecting 2 points that lie on the graph. Okay, and what we talked about before was it was easiest to pick the 2 points that lie on the axes. Here I can do that. So I've got n equals 0, p equals 15, and I have n equals 90, p equals 0, and that's that point there. So now I can draw a straight line to connect those two up, and that is going to be the graph of n against p for this question. Part B of the question was to use the graph to find the price when 30,000 plants were sold. Remember, n has units of 1,000, so 90 is actually 90,000, 50 is actually 50,000. So we're looking for 30,000 plants sold. That's this position here. I'm going to go across to where the line meets our line, our straight line, sorry, the yellow straight line. Go downwards and we see that's around 10, okay, for the value of p. So when we're using our graph that we've drawn, our straight line that we've drawn to find which value corresponds to which, of course this is going to be not an exact science. We're going to get a little bit of leeway here and there, but we can see going across from 30 going down, we're a little bit more than 10. So I would say p equals 10.1. Okay, and the price was in pounds, so let's add that in there. So part C is this time asking us what the number sold would be if we're given a price. The price that we're given is 8, so Okay, we track up from 8, see where we meet the graph, and then we come across to the y-axis or the n-axis, and we can see that's a bit above 40. I'd say that's looking around 42 perhaps. So that is going to be n equals 42, and remember the n has units of 1,000, so 42 would be 42,000 sold. Okay, so for the last part of this question, we have find the price if 90,000 plants were sold. Is this a sensible value? Well, let's go on to our graph. We see that n equals 90,000 is where, in fact, the graph crosses the y-axis. So we know if we track downwards from that, we're going to get an x value of 0, or in other words, p equals 0, or £0, and that is not very sensible at all because we're not going to be selling something for free. Okay, so something is not 100% correct with this model. That's what we can say, right? So to answer this question, is it a sensible value? No, it's not, because we can't sell something for £0. Okay, and what does it mean? Now, the question doesn't ask this, but it could be something that is asked. Well, it means that the model is not suitable for when the price gets between 0 and 1, perhaps, or when the number goes up to 80 or 90,000. Then the model isn't realistic anymore. Okay, so that's all of that question there, part A to D. So thank you for watching this video. If you did enjoy it, please remember to like and subscribe. And remember, you can always comment down below any questions that you might have from this video or any other topic that you'd like me to answer.